Hello and welcome to another Solana tutorial. Today we're gonna talk about my favorite hack. This one is my favorite hack because it's so simple for the attacker and it's somewhat difficult to mitigate against. But since we are talking about program security, we're also gonna talk about how we can prevent our programs from being hacked like that. So, yeah, it's gonna be a fun episode. Let's get to it. So, last time we built this super secure program, we're gonna recycle that program and just adapt it a bit. Well, actually, we're gonna just use some aspects of it. Really, we're gonna build a new program. For those of you who didn't watch that previous video or don't remember because it's been a while, basically, we had player accounts and then they were competing against each other with some random numbers, and in the end, a winner was chosen. We're gonna do a similar thing, but we're not gonna let two players play against each other, but we let one player play against us, the casino. So it's a classic gambling application. We're gonna basically build a Coinflip program. That's the simplest thing and people love their coin flips. Let's build it. Let's do it. It's gonna be so simple and it's gonna be so simple to hack as well. You can already start thinking while I develop this how you would exploit it. Before we can exploit something, we actually need to have something to exploit. So here we go. Let's build a program. And I'm gonna check out a new branch. How do we call that? Personal favorite. Let's see what we get if we get something with Kes. Yep, why not? This is gonna be my program address. Because I don't want to overwrite the previous program because I told you that you can find that on Devnet. So we change to this. Let's see if we can build that. Meanwhile, we can already start implementing the things we want to change. Do we even need player accounts or something like that? Not really. Basically, I just want to have a treasury and a player who signs. So we're going to have a treasury. Gonna make this pretty simple. Make the player to a payer. This is a treasury account. We just get a bump. Just so we store something. So all that does is just init that account. And the account holds nothing but 1 byte for the bump and the sol, but I keep them in the Lampert's field that every account has, so I don't need to specifically keep that somewhere else. So let's call them Coinflip. Takes the player, the treasury account, system program, and that thing for the randomness. Pseudo randomness. Again, same thing as last time. Don't try to attack my pseudo randomness. You could do that, and that's not where I see the issue here. Assume that that randomness would actually be legit randomness. So really, all I'm taking from the previous program is this get random number function. But this time we actually only need one random number. We actually only need one random byte. We need one random bit. Bool. There we go. We have a bool. So that's not the important part. Essentially, we get a random boolean, true or false, from a recent slot hash. But again, you can pretend that this just is actual randomness. Let's get to the actual function. So we call it flip a coin. And we determine if the player won with this random boolean. If you win, you have won. Else, you have lost. Better luck next time. And that's pretty much already our entire program, right? We're gonna add a little bit more, but that's the essence of it. We create a random number, or we create a random bool, and then if it's true, you won. If it's false, you lost. And of course, we want to do something on winning and losing. But let's see if that already works. It's always good to test also midway if your stuff compiles and if you can run it the way you intend to run it. Because that's the minimum example. There we go. Compiling in 8 seconds. That's how I like it. So I should be able to init treasury. Init treasury needs payer because the rest should be auto-derived. Keeper 1 is in my wallet, right? Yes. Okay, cool. We're just gonna use PowerShell because for some reason my Linux doesn't like Node at the moment. Oh, I didn't deploy the program. Of course, this is not gonna work. My brain is still faster than the execution. Okay, And also it can't open that file. Okay, that's fair. Gotta first deploy this. There we go. Now that's better. Try again. And boom! My signature is here. Perfect. Check that out. That shouldn't be anything surprising. I essentially just created an account that holds 1 byte. This one, the DSTS, that's my treasury. 9 bytes. Nice. So we have a treasury account. Perfect. We're gonna use that to hold the funds that you can definitely not drain. Haha, right? Because that's a very fair game. Let's check how fair that game actually is. Flip. We call the flip, and the flip needs a player. That's gonna be my key pair 1. Sysva I need to specify because that's just an unchecked account. The system program you will find yourself, and the treasury account you will also find yourself. Cool, so I'll just provide that. And let's do a flip, because that is taking so long. Let's do another one already. So here we just pay 1 transaction fee, and we flip a coin. We calculate some random number, and this time it's true, so we won. Nice. When we do it a second time, let's see if we're lucky again. No, this time it's false, and therefore we lost. So seems like 50-50, because it should be 50-50. The 50-50 comes from here. Modulo 2 should only give 2 possibilities, and one of them is 1. So yeah, that seems to work. Sometimes we win, sometimes we lose. Great. You can already start thinking about how you would exploit that now. But to make it more interesting for you to exploit that, let's add some financial incentives. Because what's a Coinflip program if you can't actually win something? That's what makes people play. The potential to win. So, before we flip a coin, we have to pay a fee. Wait, hold on. Why do we make this so complicated? I don't need to pay this up front. Let's do that here. When you lost, Coinflip fee, I don't know, 0.01 sol or something. And the fee is equal to the price, of course, because 50-50 chance. 50% chance you lose that, 50% chance you win that. Okay, so if you lost, then we transfer from your account to my account with the system program the Coinflip fee. And that's a regular CPI. If you've won, then we do the same thing, but from the treasury to you. And here, I don't need to do a CPI to the system program, but since I own the treasury account, I can just directly borrow Lamperts and send it to you. So let's see if I remember how that worked. Was it in the account info that try borrow Lamperts mutable? If that doesn't work, then we just raise an error. Cannot mutate immutable variable. Okay, let's do some checked stuff. Why not? Check subtract. That's safer anyway. The runtime is gonna make sure that I don't just create Lamperts. I can't just create or destroy Lamperts. So I need to add the same amount somewhere else for that to make sense again. Temporary value dropped while borrowed. Let's do one-liners then. I'm not sure about those, but I want to learn. That's why I do it differently. Because if I never try new stuff, then I never learn. Unused return value. That must be used. I don't care about the result. It's gonna work, right? Although if both don't work and I ignore both of them, that's also not so nice. Actually, can I here just unwrap? That's actually the nicer way to do this. That's quite a line. That's quite a line full, huh? Quite a line, but maybe that actually works. We'll see. Cool. And here you complain about what exactly? That I don't do anything with that result, right? Yeah, same thing. Okay, so I'll just raise it. If that errors, then I also error. Okay, so if you won, I transfer from the treasury to you, and if you lost, I transfer from you to my treasury. Safe, right? What could possibly go wrong? It should be fairly obvious what could possibly go wrong here, huh? In fact, I'm gonna demonstrate by just executing a flip, which is definitely gonna fail. Why? Well, neither the treasury nor the player have any funds. Well, actually the player does have funds. I'm playing with my program authority, so oops, I spoiled something. Oh, my bad, my bad. You think it goes through or it doesn't go through? 50% chance. It does go through, which means what? Who won? That's correct. Me. You lost. No! You won. So clearly something is not working with my transfer, is it? Because you were playing, you were winning, but you didn't really win anything, did you? Huh. Okay. Apparently what I have here doesn't really work. Because I did not deploy the program! That's why! Classic! Classic, of course. You gotta deploy the program for changes to take effect. Okay. Yeah, man. Classic, stupid beginner mistake. I'm not a beginner. I make that mistake constantly. Also yesterday. Just don't deploy the program and be like, why is it not working? I'm also an idiot because I don't implement that correctly. There we go. Now even the simulation doesn't accept that transaction because you are winning, but then we panic at the unwrap of a none because the unwrap, so this thing, the checked sub, failed because we don't have any lamperts on there. However, if in the simulation we would have won, and this is the fun thing, if in the simulation we lose and then on the cluster we won, then on the cluster it fails. So this is why the simulation in this case doesn't give us 100% accurate results, because it still depends on some other numbers that on the cluster are different than in our simulation, because random, well, pseudo-random, dependent on the slot hash really. So we can look at that, and this is still not guaranteed to have gone through. It's guaranteed to have hit the cluster, but maybe it failed. It did. It did fail. For the exact same reason, unwrap of a none, because we have actually won. But in the simulation, we have lost. So this is fun, and keep that in mind. It will also be relevant for our attack, this knowledge. But I don't want to give it away yet, so just keep in mind that the simulation result and the actual cluster result can differ. They don't have to. Also, if I feel lucky and I'm like, ain't nobody wants pre-flight checks, then I can skip that simulation because we might win in the simulation but actually lose on the cluster. And if I just don't simulate, then we just see what happens on the cluster, right? We just see what the validator decides. And in this case, the validator decides that we have lost again, that we have won again. And one more time, maybe we lose this time such that the treasury finally gets some funds. Yes, this time we have actually lost, which means the system program was invoked and we actually paid the treasury. So we can see that here we actually paid to the treasury this amount. And now we can also lose, because now that treasury actually has some funds. I'm gonna flip one more time and hopefully this time win. Actually, question to you. If we win now, do we get that 0.01 sol from the treasury back, or will it fail? Because that's an interesting question. Because there was something with rent exemption of accounts and I can't get under the rent exempt minimum. Does that apply here? Question to you. This succeeded because it definitely succeeded. Whether or not we win, it would have succeeded. And did we win? No, we lost again. Damn it. To answer the previous question, for two reasons, it would go through anyway. The first reason, well, we funded the account in the beginning when we initialized it. There we put on the minimum for rent exemption, so it's fine. And if we subtract those 0.02 sol, then it would still be rent exempt. That's the one thing. And the second, even if there was exactly 0.01 sol on there, on that account, then I could still take exactly 0.01 sol, because that would make it 0. And I can make an account 0 lamperts. I can only not make it between rent exemption and 0. Anything in between there is not valid, because we don't do rent on Solana anymore. It always needs to be rent exempt. But if it's 0, then the account will just be deleted. I can remove all of the sol from an account. That's fair game. I would lose the data on it, obviously. So the discriminator for that account, I would lose it. This was just an excursion to rent exemption because it's a interesting topic and can cause errors. So if you ever wonder, why can I not send 0.000001 sol to an address that has no funds yet? That's why. So we can now win, we can now lose. Perfect. Which brings us to the point where we can start hacking this. This one should be very simple for you to hack, actually. I like this. We're building up my idea of the hack such that it will become very obvious what we're doing. Here it should be fairly obvious how you can just extract all the money from the treasury. No? Yes? No? Maybe? What could you do? I mean, we've been talking about that for the past 10 minutes already. How can we ensure we cannot lose money? Well, easy. We play the game without having money. That's fairly simple, huh? So if I get myself a fresh account, we're gonna get ourselves a bro who's broke. Bror. We're attempting to hack now. Obviously, if I have 0 sol, then I will never be able to win. Why? That's correct, because I can't pay for that transaction fee. So already the transaction, well, I'm skipping pre-flight. But this transaction doesn't point anywhere because it was never submitted because we couldn't pay. And if we wouldn't skip pre-flight, then we would see it in the transaction simulation. We can't debit an account with no record of a prior credit. I've seen that so many times, I know that warning by heart now. Because I'm so broke, that's why. There we go, so broke. Attempt to debit an account, but found no record of a prior credit. Poor me. Or poor Roar. So how much do we need to send him such that he can play but cannot lose? Let's make a quiz show. The lights are on. How much do we need to send to that address to perform our hack? A. 0.000005, aka the amount for one transaction fee. B. 0.01, aka the amount for a game. Option C. 0.010005, aka the amount for a game plus one transaction fee. Or option D. 0. And I need to pretend that I'm not thinking here now. 0019 for no reason. What is your guess? Lock in the answer now. And if you're like, wait, hold on, I need to get my CLI out, well then do that. If you said D, then you are correct. If we only send the amount for one transaction fee, well, first of all, we can't even do that. So even if I tried, allow unfunded recipient, there. Transaction results in an account with insufficient funds for rent. What does that mean? If I would send less than the rent exemption, so for instance, just this much, to an account that didn't have any Lamperts before, then it's less than rent exemption and the runtime won't allow that anymore. It used to and then subtract rent, but we don't do that anymore. That was disabled because too much compute. This is definitely the wrong answer. How about this one? If you said B, then you were actually quite smart. B is actually a pretty good solution. We'll get to why. Why is B so much better than C though? Well, obviously, if we have C, then we pay for the transaction fee and we still have enough funds to actually lose. And the goal was to not be able to lose. So C is not such a good strategy because if we play once and directly lose, then all of our money is suddenly gone and we didn't win anything. And why D? Solana, rent for a 0 byte account. Oh, I made a mistake. I wanted to write 0 here. my bad, sorry. So essentially 0.0009. This is the amount for rent exemption. But if we just have the amount for rent exemption, then we can also not pay for a transaction fee. That's the bad thing here. So if I have that much, I can literally not even transfer it anywhere because I can't pay for a transaction to do anything. So an account that holds exactly that much money is basically screwed. Unless he finds another account who fee pays that he can remove that. Yeah, so that's a continuation of our excursion to rent exemptions. And basically if I have that number and I add that number, Like the minimum would be this. The minimum for one transaction such that we can't lose is this amount that I need to transfer there. But you're right, if I transfer B, then I have more chances of playing. So really any value between this and this is a good answer. Cool, that was my episode of Who's Gonna Be a Millionaire? You, because you're gonna hack all the Coinflip programs. So let's actually attempt that. If I send that much, there we go. That works because it's above rent exemption. So if we now do our hack, then we have enough funds to pay for that transaction fee, but we do not have enough funds to lose. Isn't that fun? We can only win. Or pay for a transaction fee and lose and then the transaction fails. But that's the worst that can happen to us. The worst is we lose. Hold on. Right. Welcome back to the issue with the simulation. In the simulation, we have lost. So the transaction failed. So our transaction didn't even go through. So it wasn't even submitted to Devnet. Because the simulation was like, you don't have enough funds to pay for that. Whereas on Devnet, the situation might have been different, right? So what we want to do again is once again, skip pre-flight. We don't care about the simulation. If we lose, if we happen to lose, okay, but then we at least want to lose on Devnet and not just in a simulation. And maybe we win on Devnet. We don't know because random. So this time it's definitely gonna be submitted to the cluster. And then we can check here if we win or lose. And here we have lost. We have lost, we get an error, we had to pay for that transaction fee, but we didn't pay the flipping fee because we couldn't afford it. That's also why the program stopped with error. So all we lost is a transaction fee, which is not too bad, right? It's a few orders of magnitude less than what we could have won. So the expected value of such a transaction is actually quite high. Point is, this was a risk we are totally willing to take to pay that transaction fee because we had the potential to actually win, but all we could lose is the transaction fee. So, now we're in a pretty bad situation though, because now we have just enough for rent exemption, which means we are stuck. We can now not do anything anymore. I'm gonna do pre-flight checks again to see, but here it will already tell me that I will not be rent exempt. Even if I was winning, the program doesn't allow me to submit the transaction because I can't pay the transaction fee before the program is executed. For exactly that reason, because there is this chance that the program might error and I might not receive those funds. So that's why even if the program were to 100% always hand me that 0.01 sol, the validator would still not accept it because he can't be sure that the program does it. So he will check that I have enough for the transaction fee before my transaction actually gets executed. That's why we here fail with transaction results in an account with insufficient funds for rent, even before the transaction gets simulated. Does that make sense? I hope so. So now we're stuck again. We cannot play because we don't have enough funds, even though we would have enough sol for paying for transactions. Like the amount, we can pay for a few more transactions with this. Problem is, then we don't have enough for rent anymore. So, gotta transfer some back to this guy. You don't see this because I'm in the way. This time I could just pay for one transaction fee. I mean, this is a pretty ridiculous transaction where we pay one transaction fee to send one transaction fee worth of sol to that guy. Kind of reminds me of Ethereum, where people pay hundreds of dollars to swap $100. Stupid, huh? On Sol we can do this. If you were to transfer that much on Ethereum, you would have to pay. This would be stupid. But on Solana, it's just a little bit stupid. I like this. I like to hack. Okay, so now let's hack again with skipping pre-flight. Let's see if we're lucky this time. Otherwise, we need to transfer ourselves a little bit more sol. Oh no, we failed again. Okay, so let's transfer maybe anything that is under 0.01 is fine. Transferred myself 0.005. Now I have enough attempts until I finally win. And do we win? Yes, finally, we actually win. Oh no. Congratulations, you have won. But I didn't get anything from the treasury. No. Maybe my program is still buggy. That's a ripoff. That's a scam. Add the Coinflip fee to the player. Okay, I'm gonna Google how to properly do that. I could, of course, do it with a system program, but that would be boring. I want to see how that's done with Lamperts directly. There, that's what I'm... Oh, I need to set it again? Try borrow mutable Lamperts. Maybe I'm gonna do that. I think I just need to double deref this. There, nah, still not. Borrow mutable Lamperts. And I double deref this. Yeah, that will do. There we go. That's also much more readable, actually, except for this. But it comes from this thing being it's a result, so we need the question mark. And then it's also a, I need the mouse. Ref mute, so it's a mutable reference of a mutable reference of a U64. So I need to double deref this. Okay, that makes sense. Sure. And we don't do any checked adds now anymore because, right, the player will always have enough funds, right? And if that value gets negative or flips over and is too big, then the runtime will catch me anyway and kill my program. So what's the point of error handling if at some point I'm gonna fail anyway, right? Sorry, dear hacker. It was my mistake that you couldn't hack me. I would have never paid out anything. So people would not actually play this, I guess. They would soon realize that it's a scam. I didn't even intend to make a scam. I'm sorry. I was just stupid. I didn't know. Okay, but now comes the actual scam from the hacker. We're gonna steal all of your treasury funds. Now that you're actually willing to pay them out. Ha 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 ha. There we go. Did we win or did we lose? Yes, success. Nice. And thank you for the funds. We are now almost rich. Nice, nice, nice. There, we've won and we actually got the funds even without calling the system program. We can do that because the treasury account is owned by the program. So the owner of the treasury account is my Coinflip program, my casino cash whatever program. That's why I can do that. I can do that on any account, but I can only do that on accounts that I own. Okay, cool. Maybe we already learned something, but let's keep talking. Did we then lose it again? No, we won again and we completely drained the treasury. Ha ha ha. Ha ha ha. So now the treasury is playing the same game on us where the treasury can't lose anymore. Let's hopefully see that if we hack it again, because we're too stupid to see that we've already depleted it. Actually, before I do that, I should have transferred my soul somewhere else, right? Such that I can't lose it again. If the treasury wins now, then I fund it again. No, but I have won again. I'm a winner! But then SBF panicked because we subtracted with an overflow. Yep, we went under. Subtract and then we had an underflow really. But yeah, you call it overflow, that's fine. So it panicked, so we again had to pay the transaction fee. But at least we didn't lose anything, right? But the treasury can also not lose anything anymore. The treasury is already drained. And such that does not happen, let's fund the treasury properly, such that people are actually confident to play this. There we go. If we now check the treasury, now it's got 3 souls, so it's got enough funds to get drained and to have a lot of games being played. 300 to be exact. Well, 300 times losing, but the chances are 50-50, so it should stay at those 3 sol if people played normally and don't hack it. Okay, we've spent a lot of time in the hacker's mindset. So me as the hacker, I could, whenever I win, just remove all of my funds, keep enough for a transaction fee, and do the same thing again. And that way, drain the treasury by always just having this part execute, and if this part happens, then it fails. So we've spent the time in the hacker's mindset. Now we need to come back to the program developer's mindset. How can we mitigate that? How can we make sure that this doesn't happen? That the player does not get to play if they don't have enough funds? Any ideas? And I automatically wanted to do it like that in the beginning already. And then I was like, no, let's do it the wrong way first. What do we need to check for? Well, that the user has enough SOL to pay for this. So how do we do that? Well, either we add a check here of being like, if balance is larger than something like, if the Lamperts, let's do smaller, let's do a guard. If it's smaller than the fee, then I error. How did that go again? I just need to try out so many things until it finally works with the types and stuff. But now it seems fine. This would fix that attack, because if here in the hacker, that's my balance. If I would transfer out those 0.02 such that I can't lose them, transfer them. Where should I transfer it to the treasury? I'm going to transfer to the treasury just so I can't lose them. Anyway, I would transfer it to some safe account of mine. Doesn't really matter. Point is, now I can't lose them anymore because I don't have them anymore. And if I now hack again, wait a second. I'm forgetting that I need to build and deploy this. Otherwise, this is not gonna be a protection, is it? All right, but now my program should be safe against this kind of attack. It was successful. Shit! It's not safe. What did I F up? If my Lamperts are smaller than the Coinflip fee, I'm borrowing Oh, treasury. Man, okay, I see. I of course need to check the player, not the treasury. If my treasury has insufficient funds, then I should also not let the player play. That's true. But really, then I don't really care. Okay. Well, copy paste. Copy pasta. The classic copy pasta. Okay, gonna transfer that out again just in case we lose. Heck. There we go. That's what I want to see. You still pay the transaction fee, but my program be like, anchor error thrown in. Insufficient funds. Insufficient funds for flip. Oh, you don't see that. Yeah, that's a custom program error. Custom anchor program error. Insufficient funds for flip. So I protect against you draining me with an account that doesn't have enough funds. That would be solution number 1 to this. Gonna commit this as solution 1. That's one way to fix it. There is, of course, another way that you maybe prefer. We don't need to do that check if we just transfer the fee in any case. So we transfer the fee no matter if he loses or wins, but we then, when he wins, refund twice the fee. That's another quick fix how we can solve this. So this would be my solution 2. Build it, deploy it, and hope that we win. No, actually, I hope that we lose, because I want to showcase that that also works. Wait, now the winning and losing, I'm switching in my head, like, who am I now? Am I the program developer or the hacker? Do I want to protect against or want to hack? Because at the moment, I cannot perform the hack. That's my stance. I'm trying to prove to you that even if the player wins, he cannot drain my treasury. Yeah, because we error. Oh no, actually, that's even better, right? We don't even check if you win or lose, because in any case, you don't have enough funds. So we don't even check if you would win or lose. The same with the error before, right? If you don't have enough funds, then we display an error. And personally, I actually prefer this because I love the 0x1 so much. 0x1, insufficient funds. You need that many. And you only have that many. So top up your account, goddammit, to play this game. So we're safe, right? Our Coinflip game is super safe and cannot be hacked. Cause we're so good programmers. And we think of every freaking edge case. And you have no chance of draining my treasury that holds 3 SOL. Is that true? Is it? So now that we spent 2 minutes in the programmer's mindset again, let's get back to the hacker's mindset. Because obviously, I wouldn't do this if you couldn't hack this again. The question is just, how? How can we still get access to those sweet, sweet funds? Sweet, sweet funds. Do you have an idea? This is the part of the video where I let you think. Think about it. How could you hack that now? This state of the program I will, after the video, deploy under this address on Devnet, such that you can play around with it. If you want to play around with it now, go ahead. Check out that program. Check out the current hack script. It's not that difficult. It's just calling the flip. The treasury is also set up, and the treasury holds funds for now until one of you drains it. So for testing, maybe you want to check if the treasury actually holds something still and top it up if somebody else drained it. Because it's just Devnet Sol, right? But here we go. This is my Coinflip program. Go ahead and freaking drain it. Drain it if you can. Drain me if you can. Yeah, try it. Try it out. Try it out, try it out, try it out if you can, if you have an idea of how to do that. And if you don't have an idea and you're like, well, Andy, but I don't even know how to think about that. Let me give you a hint. The hack I'm proposing is very similar to what we have already been doing. It's the exact same idea. That's also one reason why I set it up like that, to get you in that mindset. So essentially, continue thinking about that. Okay, we did our hack. The developer was smart enough to mitigate against that. Let's do another hack until the developer is again smart enough to mitigate that as well. But we're still here. The developer was a little smart. He did change a little bit, so we can't just drain the funds without holding enough Sol to pay for the fee. But what can we do? What can we do to still avoid paying this? And now is the point where I'm going to get to the solution. So if you still want to think about it yourself, pause the video. Right. So we are somewhat limited by this instruction, right? Because we need to have enough Sol to pay for this. Otherwise, we will never get to the point in the execution where the program actually lets us access the treasury and get some lamperts from there. So we need to have enough Sol here. But how can we still avoid actually paying this if we didn't win? Because I'm okay with paying for this if I win. Because if I win, I get more than I lost here. So I won one time the Coinflip fee, right? Then I'm fine with that. If I win, I'm net positive and I'm like, okay, I'm fine with that. I accept that transaction. Do you already see where I'm going with this? However, if I happen to lose, I can be like, well, too bad that I lost. It would be a shame if that transaction would fail, huh? Ha! Ha! I love this. I love hacking. So essentially, it would be nice if after we've won or lost, we could be like, well, if I did not win, I'm just gonna error. I want to win though. Wouldn't that be fun? Wouldn't that be fun if we could do that? If we could just add that into the program? Because then we would always win. Well, if we would lose, then we would just pay for the transaction fee again. So similar result as before. Obviously, as the hacker, I cannot modify the program of the developer. Obviously, this is not going to be possible for us. But what is possible for us? How can we still achieve the same thing? We cannot change the instruction of that program, but what can we do to our transaction? Yeah, that's right. We can add another instruction. In our hack, we can first execute the program instruction and then do something else, like call our own program that now does some checks, right? We could now write our own program and be like, if my balance is larger than 0.01, I'm good. But if my balance happen to go below that, then I will fail. Or I could even take it as a program input. This is what I expect to happen. Like, this is how much Sol I expect to have afterwards. And if I don't have that, then I just let my instruction fail the entire transaction. Because remember, a transaction is atomic. So as soon as one instruction fails, all of the instructions get rolled back and none of the state is persisted, except for the transaction fee that is paid. And if it was a nonce account, then the nonce advance also is, but we're not working with nonces here. So that's the idea. Now, I'm a lazy person. I don't want to write my own program for that. What other possibilities do I have to reach the exact same thing? Well, quite easy. We're gonna take advantage of the system program and the system program failing if we don't have enough funds to do what we want to do. That's a simple check for us if we have at least that amount of balance. So actually for that, I will create myself a safe account so that I don't transfer it back to the treasury, because that's stupid. My bro is gonna have an account thefts. Yeah, we go with that. I like that. I just like my vanity addresses. Appearance is everything. So I have the key pair for that somewhere. I don't need the key pair for that, but that's my safe address. And I can now check my balance, then perform that instruction, and then transfer out my entire balance that I had before to make sure that I'm net positive. That's the simplest way to think about that. And then it works with any amount of SOL that I have on there. I could, of course, also always make sure that I just have 0.01 on there, and then I always transfer out the 0.01. That's the easier option. Then I wouldn't need to check for balance here. So option number 1, we transfer from my key pair to my safe. Lampert's, well, as we said, the simple version is just the amount that we can win. Lampert's per sol. Transfer, that gives me an instruction, perfect. And then I just add that instruction as well. Right, so that's the simple and quick version. I just need to make sure that my balance is actually between 0.01 and 0.02. So less than 0.02. Because for now, I can't play the game because I don't have enough funds. Gonna have to transfer myself a little bit more. 0.01. And now I have enough to play the game, to flip a coin, but I still have not enough to lose and pay another 0.01. So what's gonna happen if I lose and I'm doing this as well? Well, obviously the transaction is gonna fail, right? Because I won't have enough Lamperts, and instruction 2 is gonna make the entire transaction fail, which will also make that thing never have happened or not persist the changes. So even though I paid it, I got it back. I got a nice refund from the Coinflip program. Isn't that a cool hack, huh? So let's do it. Let's do that hack. Let's drain that wallet. Drain the treasury. And again, here we want to skip pre-flight, because obviously if in the simulation we lose, then it wouldn't submit it, even though we could have potentially won. Let's see if we won or not. We have, look at that. We have won. We paid the transaction fee. We started with this balance and we end up with the same balance minus the transaction fee. The treasury got drained for one fee, and the fee I directly paid to here. I could now also make a slight variation of my script and subtract the transaction fee here. Then my key pair is actually net neutral and just all of the winnings go to this wallet. But actually he still needs to pay for the transaction fee if he loses. And that happens 50% of the time. So let's double that actually. Let's make Bob win if he wins, but just so little bit that it would still be in the same range. So that's how I would improve that script. Again, the other possibility is to read my balance, but I find that quite clean as well. So let's stay with that. And let's hack again. Did we win or lose? We've won. So with a slight adaptation of my script, again, the treasury has lost. I get one transaction fee worth of SOL such that I can pay for losing the next time. And my save is still positive. So here I still won. And I can of course play this another time. Just want to see the losing case. For now we were just lucky. Did we finally lose? No, we've won again. Wow, we're just way too lucky. 3 in a row. Poor treasury. We just keep winning. Come on, at some point we gotta lose as well. But now, still winning. Do I have a bug in my program? Bit weirded out by how often this hacker is winning without even freaking having to use his nice hacking strategy. I mean, that is a streak. 1/2, 1/4, 1/8, 1/16. Probability for that is already 1/32 for that to happen if it was actually 50-50. What? You won, but the numbers are always different. I think my random number generator is a bit rigged. That's already 1 in 64. I wish I was that lucky in real life or in love. Finally, finally the streak ends. All right, I was already skeptical here, but finally we had an even number and therefore he lost. But because he added a system program instruction that transfers out that amount of sol that he didn't have anymore, 0x1. And that thing made the entire thing fail. Instruction 2 has failed. How nice. How nice is that? There. And the only thing that our bro had to pay is the transaction fee. He's not so broke anymore, is he? Because he still has his safe where he's accumulating funds. And now, obviously, I wouldn't just do this once or twice. I would do this a shit ton of times. 100. Let's start with 100. We might get rate limited. At this rate, maybe we don't even get rate limited. Yeah, so I'm just pumping out transactions. Be like, drain the program, drain the program, drain the treasury, drain the treasury, da 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 da. This is how I like it. If I am a hacker, look at all the transactions that get me money from the treasury. Ha 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 ha. What an idiot who developed that program. He didn't think about all of the attack vectors. Ha 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 ha. Yeah, that could be me. So we had 0.05 before and now we suddenly have 0.5. So with 100 flips, we made 0.5 roughly sol, which is exactly the expected value because my expected value of one transaction, 0.01 in the winning case and essentially 0, let's say 0 in the losing case, we add that together, divide it by 2. Well, actually, first we need to multiply it with the likelihoods, but since the likelihoods are the same, this 50%, I just add them together and divide by 2. And then the expected value is 0.005 for one transaction. Multiply that with 100 transactions, we shift it up to 0.5 is my expected value. And that's exactly what we see here. So the likelihood is actually around 50%. We were just super lucky when we did this earlier. And we had like, how many? 7 in a row? Yeah. And of course, I can keep doing that. I do it another 100 times and then I'll end up with 1 sol probably. Oh, if you're hacking this, then you can also see on chain how other people have hacked it. That's, by the way, another nice strategy of a hacker. Look on chain what has happened to that program before, how it got drained, and then do the same thing. And it's really not difficult, is it? This here is really like Solana 101. Any script kiddie can get you that sort of a transaction build. You don't need any on-chain program. You don't need much knowledge. Literally, you just need to manage to call the program and do a system program transfer instruction. That's all you need to do. And that's why I kind of love this hack from a hacker's perspective, because it's so goddamn simple. It is so trivial to pull off, and it has pretty dramatic effect. I can literally drain that goddamn treasury. Look at that. 1 refresh and I'm half a sol richer. There we go. Almost 1 sol, a little bit under. And if we look at all those transactions here, can have a look at that for you. Some of them are failing and I'm paying for the transaction fee, but some of them are also succeeding and I'm paying for that transaction fee, but I get enough to fund that. So even if my likelihood of winning was not 50% but 10%, this would still pay off. Even if it was 1%, it would still pay off. And here we have it. Solana is so cheap. We are burning transaction fees when we get to 0.00001. Then we're basically not winning anything anymore. So 0.01% would already just be paying for transaction fees. At a 0.01% chance of winning, it doesn't make sense to do this anymore, unless the price would be higher. But that's just some economical calculations that you got to do to estimate whether or not that makes sense. And that is not just an attack for like Coinflip programs. This sort of attack, where essentially we are after the fact doing something else, can be applied to many things. So just because we have one instruction and we say okay, does not mean that at that point that actually goes through, because there can still be other instructions in the same transaction. The first ever candy machine program was actually attacked like that. That was before my time, so I don't actually know. But I'm pretty sure that that's how they did it. Because that way, people can just analyze which NFT they got, and in case they got a floor one, like one that is not worth much, they just kill the transaction. They just error out. And if they got a rare one, like a legendary NFT, then they're like, okay, yes, I pay for this one. I pay the mint fee. And that's how those candy machines got botted. Just send a lot of mint transactions, pay the mint price, but then make the transaction fail again when you're not happy with what you got. And that's why Candy Machine V2 implemented measures against that. And now we can start talking about, well, what could be measures against that? Basically, we know that it's not over here. There could still be another instruction. Just want to brainstorm with you what we could do now. On the developer side again, we spent again some time hacking, and now we need to spend that time in the defensive mindset. Again, how can I protect against that? The issue has always been there is another instruction after our instruction. So the way we can prevent that is by checking if there is another instruction after our instruction. And we can do that with the instructions sysvar. Sysvar instructions, I need to pass that into the program, but that would be all right. I can say you're only allowed to coin flip if you also provide me the sysvar instructions. And again, in Anchor, there might be a nicer way to get it, but I don't know how, so I'm just gonna do it unchecked. This account holds the information about all of the instructions inside the transaction at runtime. So while we execute. That's also how the Candy Machine protects against that. The Candy Machine basically does not allow for any further instructions after the mint instruction. So the mint instruction needs to be the last instruction in the transaction. And it also checks for other programs, like it only allows the token program to be called and the system program, I think, and the Candy Machine program itself. And if any of the instructions is to a program that is not any of those three, then the Candy Machine will also make the transaction fail and not allow the mint, because then it's not a normal transaction. And we could also do stuff like that. With that instruction sysvar, we can also make sure that we are literally the only instruction that is called in the entire transaction. We could also, not allow anything before or anything after. And this is how you can mitigate against this attack. Or that is one way how you can mitigate against this particular attack. Should we actually have a look at that? Should we implement that? I do want to make a whole separate video about sysvars, where we're gonna talk a bit more about that. Instructions. Instruction sysvar contains the serialized instructions in the message while the message is being processed. And the layout instructions, that's what I need. Two helper functions to extract this data can be used. Oh, amazing. There. Load current index checked. Load instructions that's checked. Let's go index 1. This thing gives me a result of either an instruction or a program error. Oh, now we unpack all our Rust knowledge. We match the result. If it's okay, so if there is an instruction, then first of all, you are planning something evil, huh? And then on an error out with, that might be a bit counterintuitive of what's happening here. At OK, I'm erroring because I'm reading the first instruction. So I'm expecting 0 to be mine, and the first instruction should not exist. This implicitly tells me that I'm the instruction 0 because, I could also check that where I am. We can just for fun, for our practice, load the current index checked, and this should be 0. Yeah, and that's a protection against my attack. Now, first error we're gonna get is what? Yeah, an anchor error of an account is still missing. Not like we haven't made that mistake before. We also need to build and deploy that program. And now if I would try to hack, then it's telling me I'm missing an account because my program now only allows execution if this one is present. Yeah, sysva instructions account not provided. So let's provide this account. There you have it. You are welcome. If we do that, there we go. The program is erroring and you have to pay. And here we have it. Instruction flip. You are planning something evil, huh? And then it doesn't even let us do that. Could have added a little bit more detail for our entertainment. Let's see, what does this instruction actually have? We can look at everything. We can look at the accounts, we can look at the data, and we can look at the program ID, so everything that makes up an instruction. So yeah, we have access to all of that. So if we hack, then the program errors because you're illegally calling the system program. But if we do a normal flip, then this should work. Success. Oh, and the poor player has lost. But it's all good. We are instruction 0, as I said, and there are no other instructions. Let's do the coin flip. So that's one way how we can protect ourselves. At least against that. Do you have another idea how we can hack this? Or is it safe now? Would you deploy this coin flip program? Would you put your funds in the treasury? Probably not, because on average you wouldn't win anything, but what if the chances of winning are actually 0.49 and the chances of losing 0.51? So with enough people playing, overall you would make money. Would you deploy that? Would you put your money in the treasury? I probably wouldn't. Just because I mitigated against this specific attack, there's probably still some other things that you can do. Even if we make sure that this is the only instruction in this transaction, there's still so many other things that you can do, which we will not get into. In fact, let's conclude this video. Even if we can now make sure that we are the only instruction in the transaction, there are still other attacks that can be played on us with the same idea, just not on the instruction level, but on the transaction level. Transactions. For instance, with transaction bundling with a MEV enabled validator like Cheeto, you can basically bundle transactions, which essentially has the same effect as adding another instruction. So either the transactions are both executed or they're not. Funny stuff like that can happen. If an attacker has enough incentive to try and hack you like that, there are possibilities. And with our program, we cannot mitigate against that directly. We need to logically split that up into several things. And that's why most Coinflip or whatever gambling applications out there, they separate the paying from the paying out into completely separate transactions with a gap in between, such that we can make sure that the first transaction actually got executed before the second transaction is even played. So basically you need to deposit the fee, then you get to coin flip, and depending on the result, the deposited fee is taken or paid out. But they're in completely different transactions. You pay for the deposit first, and then some external service usually calls the transaction that makes it win or lose. Or even determining if you win or lose is done off-chain, just so it can't be tampered with by you. In our program, that would mean that we split this part where we collect the fee from this part where we calculate the winner. And even then, probably there are other attack vectors. And that's the thing, you can never be 100% safe, Because as we saw, it's always a ping pong between the hacker and the developer. Oh, I have that idea. Oh, I have that fix. Oh, now I have that idea. It's always back and forth between the hacker and the developer. If you implement the fix, then I might have another hack. But it gets increasingly difficult for the hacker to hack the more mitigations you implemented. And at some point, it's hopefully too much of a hassle for the hacker to find another attack vector to attack your program that he's just not gonna bother, because it either costs him too much money or time to do it. And that's usually where program security is coming from the economic incentive that it doesn't make sense anymore for the hacker to try to exploit you, because he can't really win anything anymore. If he would have to, create programs and execute 1,000 transactions just to win 0.001 sol, then he's not gonna do that, because he'll still be net negative. That's why even if we can't ever be 100% safe, we can get to a point where for most bad actors, it just doesn't make sense for them anymore to attack us. And if a government would attempt to hack, like somebody with like a lot of resources, well, then be it, right? If somebody with enough funds to spin up enough validators would take down Solana, the bad actor could essentially do a denial of service, and that might already be bad enough. But at which cost, right? And is it worth it to them? Certainly not worth it for them to drain your 3 sol out of your treasury. But that's it. There was another Solana program security episode. I hope that you learned something. I hope that you got a little bit into the hacker's mentality, and then also in the, oh, that's how I can protect against that mindset. And you keep thinking about those things when you develop programs. Because just because your instruction yielded okay, does not mean that the entire transaction actually goes through. That's what I want you to take away from this video, among all sorts of other things. But yeah, let me know in the comments what you want me to talk about next. If you have any idea for a hack that I should cover. Again, program security is probably my favorite topic. So I'm gonna keep posting videos in this series. And of course, also other videos where I go through the basics, like sysvars. We've got to know another sysvar today. There might be another video just on sysvars, because they are pretty helpful and interesting for a developer. And most of this is developer-focused content. So, like and subscribe, and I will see you in the next video. Until then, bye-bye. Keep hacking and mitigating.